Okay, so let's talk about those three different counting rules. One is what we call permutations. Permutations. Permutations, again, is when order matters. Order matters. Okay? So if I gave you the letters A, B, C, and D, and I said to you, how many ways could I arrange those letters? Arrange is the key word, meaning that order matters. So that's what's going to tell me to use the permutation. I'm going to have 4 items, and I want to know how many ways I can arrange all 4 items. When you're using all of them, and its order matters, you're going to then do, in this case, 4 factorial. 4 factorial. Okay, so that's case number 1, if you want to call it that. Let me bring up my calculator just so that everybody's knowing exactly how to do it on their calculator. So to do 4 factorial, I'm going to punch in a 4. I'm going to go to math. I'm going to cursor over to probability, and I'm going to choose number 4 because that factorial symbol is there. And my answer is 24. Okay. The next situation with permutation when order matters. If I were going to pick 4 letters out of the entire alphabet and arrange those letters, again, order matters. How many letters are there in the alphabet? 26 letters in the alphabet. Am I arranging all 26? No. How many am I arranging? 4. So I'm only using part of my whole amount, but order matters. That's when I'm going to say, when I'm saying arrange 4. This is when I'm going to say, hey, I've got 26 letters to choose from. Order matters, so it's a permutation. And I'm going to choose 4. So on my calculator, I'm going to first type in 26, that's how many I'm choosing from. Still going to go to math. I'm still going to cursor over to probability. Because it's a permutation, I'm going to choose number 2. It's going to take me right back to the home screen. So I'm choosing from 26, order matters, and I'm choosing 4. So I'm going to type in a 4 and press enter, and wow, those are the different ways that 4 can be arranged. Okay, does that make sense? I know we didn't get a chance to practice the counting before we finished class last time, so this is a good little refresher, summing it up. So sometimes, though, we want to arrange things from something, but some of the items are identical. So for instance, let's talk about the word statistics. The word statistics. How many different ways can I arrange the letters in the word statistics? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different letters, correct? But do I have any repeats? I do. I have some letters that are identical. Okay? So I have 10 letters, and I'm going to use them all, but I have T that repeats 3 times, right? So I have 3 T's. The other thing that repeats is what? The S, I've got 2 S's, correct? Oops. Glad you guys are awake. There are 3 S's. And lastly, I have 2 I's. So because I have identical things, this is the formula I need to now use, is I'm going to still say 10 factorial on the top. But I need to divide 10 factorial because I have identical items. So those identical items are 3, 3, and 2. So I have to put 3 factorial times 2 factorial, 3 factorial times 3 factorial.
And does that matter if you order from 2?
No, it's as long as you've got 2 3s and a 2. The order of multiplication doesn't matter, so I wanted to do it the same order there. Okay? So that's when I'm arranging everything that's there, but I have identical items. I need to divide by that many factorial of each of those items. So just so we go over that calculator part, because that's a little different, bring that calculator up. So I'm got to start with 10 factorial on the top of my fraction, so that is my numerator. So I'm going to do 10 math. I'm going to go over to probability menu, and I'm going to choose number 4 for factorial. Now, this says divide by all of these things multiplied together. If you punch in your calculator 10 factorial divided by 3 factorial times 2 factorial times 2 factorial, that is not what that says. Order of operations. So we have to tell the calculator. So we're going to put a parenthesis on our denominator. So it tells the calculator the order of operations. So I'm going to put divided by, I'm going to put parenthesis, 3 factorial, go to the same menu there and pick up your factorial symbol, 3 factorial again, and 2 factorial. And I'm going to close my parenthesis. And I'm going to hit enter. Okay. So three different ways I'm going to use permutations. Arranging things, order matters, and I've got so many items and I'm using all the items, I'm just going to say factorial. If I've got more items than what I'm using, so for instance, I'm going to use the numbers from 0 to 9, so I have 10 available, but I'm only choosing 3, I'm still going to say 10 permutation, because order matters, choose 3. If I have the situation where digits or items are repeated, then I have to use this formula. And that's all about permutations and all about when order matters. Okay? The last counting principle we covered was combinations. And this is when order does not matter. And that's when you're going to use that, I think it's number 3 on your calculator, where it says NCR. Okay? NCR. I have a group of 10 students. And I want a subcommittee of 3 students. So order's not going to matter, because it doesn't matter if I picked Aaron first and Donald second and Jemiah third. They're all 3 got the same position, the position of a subcommittee member. So order doesn't matter. So that's when I'm going to say, hey, I've got 10. I'm going to put in a combination because order doesn't matter, and I'm going to choose 3. How many different ways can I do that? Does that help from the other day? Putting it in your calculator so we follow through. I'm going to put in 10. Of course, going to my probability menu, and I'm going to choose number 3. And I'm going to choose, from that 10, choose 3 of those students, and it would be 120 different subcommittees that I can make. Okay? That's a little better, I think. So hopefully it'll be a little better. I'm going to put you in groups again, and you're going to do those problems together as groups, talk them through, decide if order matters or if order doesn't matter, and which way you're going to do that calculation. Then we'll come back together again and make sure that we've got them and talk about them, okay? Okay. So everybody's had a chance now to take a look at these problems. Let's come back and talk about them, make sure we understand them. Okay, so the first one, Lady Antebellum songs. A fan of Lady Antebellum, please. Music plans to make custom CD with 12 of her 27 songs. How many different combinations of 12 songs are possible? And would it be practical to make a different CD for each possible combination? First, tell me what you did. Is it a combination or a permutation? It is a combination. So I'm going to use my combination. I've got 27 to choose from. It is a combination, and I'm choosing 12. When you did that, that's going to be a pretty darn big number, isn't it? Somebody tell me what that number is. Wow. Okay? So knowing that it's 1,738,360, would it be practical? No. Okay. This is the one that stumped a lot of you, and I completely understand why. Because if you've never played blackjack, you know, what happens in blackjack is that from a deck of 52 cards, everyone is dealt their first card. Then everyone is dealt their second card. Wow, okay. Oh, the first question is wrong? Oh, 17 million. Ah, thank you. So it's 17 million. 860. I obviously heard that incorrectly. Okay, good. I'm glad you corrected me, because if not, at home they would be going, what? Right? Okay. So on this, though, on blackjack, so then after everyone gets their 2 cards dealt to them, then they decide if they want a hit or if they want to stay. And what they want to do is get a addition total to 21, as close as they can get without going over. If they go over, they're broke. Okay? So when you receive those first 2 cards, it doesn't matter the order which you receive them, they still count as the same card. So if you were being dealt an ace on the first and a jack on the second, it's still 21. If you were dealt a jack the first time and an ace the second time, it still counts as 21. But the confusing part of it is, so it doesn't matter what order I receive the cards, it counts the same in the game, but to get the number of possible ways, I have to say it does matter to get my count. And I know that's very confusing, but that's why I wanted to put that problem up there. So in essence, it really is a permutation. So I've got 52 cards, and I'm taking 2. And when you do that, what is my number? What is it? 2,600? 52. Okay. And of course, if they want to know the probability, what am I going to put there? 1 over, okay? So there's 2,652 possible ways. Am I right? Everybody, it would be 2 over, because I could get the ace of clubs first and the ace of spades second, or I could get the ace of spades first and the ace of clubs. So that's why there's 2 possibles that would still get me what I wanted out of the 2,652, exactly. And of course, if I reduce that, what do I end up with? 1,326? So that one was a tough one. I know, that one was a tough one. Absolutely, and you're going to get the exact same answer. Very good. So, just so that everybody knows, whoops, wow. Let's check that clamp. Okay, so the other possible way as George said, he thought about it as he put himself in that situation, and I could get the ace of clubs first, one card out of 52, and means I'm going to do what? Multiply. There's only one ace of spades out of 51 cards that are left, correct? And I absolutely could do it that way, but that's one possible way to get it. So this is kind of like one possible way to get it. Or, plus, I could say 1 being the ace of spades being drawn first out of 52, times, because and, then the ace of clubs, 1 out of 51, being drawn the second time. And if you do this, guess what you're going to get? 1 out of 1,326. So either way absolutely works. Very good. Good thinking. Okay. Next question here. Presidential candidate plans to bring her campaign by visiting the capitals of 4 of the 50 states. What is the probability that she selects the route of Sacramento, Albany, Juneau, and Hartford? Is it practical to list all of the different possible routes in order to select the one that is best? Is that a permutation where order matters or a combination where order doesn't matter? It is a permutation, exactly. It is a permutation because there will be a big difference in my route in the order of the cities that I visit them. So we could probably think about it a little easier here in Delaware where we are. We could say, hey, of all the towns in Delaware, maybe I want to have, I don't know how many towns there's in Delaware, I really don't know. I have no clue. Or even counties, there's 3 counties. I could choose Sussex, then Newcastle, then Kent. I could choose Newcastle, then Kent, then Sussex. I could choose Kent, then Sussex, then Newcastle. So every time I do that, when I change the order, my route changes. Okay, so since it's a permutation, I've got 50 states to choose from. And permutation, I'm choosing 4. So somebody tell me what that is. 5,527,200. Okay, so is it practical to list all the different ones? Nope, I'd want a computer to do that for me really fast, right? Yeah, excellent. Oops, that was the page we were looking at, and here we go with a classic counting problem, in that to determine the number of different ways the letters of the word Mississippi can be arranged. Soon as you see that word arranged, you should think permutation or combination? Permutation. Permutation. So I know it's a permutation, but this is a special permutation. Back on number 11. Did it ask me the probability? What is the probability? So what is the probability? Good. What is the probability? There's only one route that's up there, so the probability would be 1 out of it. Excellent. Yeah, make me finish the problem. Absolutely. Okay. So why is this special? We know it's a range. We know it's a permutation, but it's special because of? Yeah. I've got identical items up here, don't I? Okay, so in the, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 letters. So I know I have 11, and I know I'm doing a permutation because it says arranged. And, I know, but where's the problem here? Okay, so I've got to stop and say, hey, wait a minute. I have 4 S's, 4 I's, and 2 P's. So now I have to treat that special. I have to say 11 factorial divided by 4 factorial, 4 factorial, and 2 factorial. You got an answer on that one? So there's 34,650 different ways to arrange those letters even when they have identical.
And then when entering it, you use parentheses.
You have to use the parentheses when you put it in your calculator. Yes. If not, you're going to get a much larger answer. Okay? So how about that good old lottery? Winning the jackpot of the Connecticut Classic Lotto requires that you choose 6 different numbers from 1 to 44. And your numbers must match the same numbers that are later drawn. The order of the selected numbers does not matter. Right there it tells you it's what? Combination. If you buy 1 ticket, what is the probability of winning the jackpot? So first I got to figure out what? How many different ways I can choose 6. So, and only 1 winner, right? So really it's 1 over, how many numbers do I have to choose from? 44. We know it's a combination and we are choosing 6 numbers. I know this is a big number. 0552. So 7,059,052. 1 out of that. Not much chance, huh? Okay. So this problem I always like to talk about a little bit. Combination lock. And that uses 3 numbers between 0 and 49. And the numbers have to be selected in the correct sequence, right? So think about those lockers that are with the round dot, the round knob that are a combination lock. So you have to say, hey, if the combination was 49, 29, 2, you can't do 2, 29, 49. It won't open, right? So that combination lock, that combination has to be in a specific order, okay? So how many different combinations are possible? Is that really a combination or is it really a permutation? It is a permutation because that is, order does matter. Okay, so I've got how many numbers am I choosing from? 50 because I include 0 permutation and I need 3. Okay? Can we tell me what that is? 608 or just 600? 600. 117,600 different combinations for that lock. So, which of the 5 rules? Well, the rules is the permutation where I have an amount and I select 3. Is the name combination lock truly appropriate? No. Can you think of a better name? Go ahead, tell me your name you came up with. Permutation lock. Simple and easy because now you know, right? Maybe it just should be a number lock or what have you, but only the people who take a class and know the difference between a permutation and a combination would really know that, right? Okay. So the Technomill Corporation must appoint a president, chief executive officer, a chief operating officer, and a chief financial officer. It must also appoint a planning committee with 4 different members. There are 12 qualified candidates, and officers can serve on the committee. So part A, how many different ways can officers be appointed? Is that a permutation or is that combination? It is a permutation, because when I select the first one, the first person I select is going to have the role of president. The second person is going to have the role of chief executive officer, and so forth. So that order makes a difference. So if I'm selected 4th, I could be the CFO. But if I'm selected 2nd, I would be the CEO. So that way order matters. So there are, to find A, I'm going to do, how many am I choosing from? 12, permutation, 4, which is 11,880. How many different ways can the committee be appointed? Then it does go to say, hey, you know what? Even though I chose my officers could serve on that committee. They're allowed to serve on the committee. Combination or permutation? Combination. It doesn't matter the order. They're still going to be on that committee. There's no rank there. So it's going to be 12, combination 4. Can you tell me what that is? 495. Okay, excellent. Then C says, what is the probability of randomly selecting the committee members and getting the 4 youngest of the qualified candidates? 1 out of 495. Because I could choose the first youngest, the second youngest, the third youngest, the fourth youngest in that order. But I could choose the second youngest, the fourth youngest, the first youngest, the third youngest in that order. And so the order at which I select them, as long as I selected the 4 youngest, would not matter. So therefore, this is 1 out of 495. Good. And then we get to World Cup soccer. Every 4 years, 32 soccer teams compete in a world tournament. How many games are required to get to the one championship team when you begin with a field of 32 teams? How did you think about that? What did you do? No one wants to say.
Order doesn't matter, so it's combination.
Okay.
It doesn't matter how you pick the teams.
For the number of games. Correct. Okay. What did you come up with?
496.
496. You may agree or disagree. No one knows. So you did 32 combination 2. Okay. Okay.
2 teams picked for each game.
Okay. And that's what we want to think, right? Okay, but, here we go. Here we go. How many teams do I have to start with? The very first time I have 32 teams that I'm starting with, right? So, and if each of those teams are going to play another team, how many games are there? 16 games, yes. Do you agree? 16 games. So the first step out of the gate, first elimination, if you want to call it the first elimination round, 32 teams, I'm going to have 16 games, right? So this is my first. Now my second time comes up. How many teams are now gone? 16 teams are gone, aren't they? Because that was a elimination round. In those 16 games, 16 teams had to lose and 16 teams had to win. So now I have 16 teams left, correct? And if I have 16 teams left, I'm going to have 8 games. Now I'm down to the third leg of my tournament. Once I play 16 teams, play 8 games, 8 of those teams are eliminated, aren't they? And I have 8 teams left. And if I have 8 teams, how many games is that? My fourth round, wow, I'm down to how many teams I have. How many teams do I have left? 4 teams left now. How many games is that going to take? 2 games. So, how many teams am I down to? 2. So now I have the championship game. And in my championship game, I should say game, not games, I have 2 teams, but those 2 teams play 1 game. So all you got to do is add them all up. So I've got 16 plus 8 plus 4 plus 2 plus 1.
Actually, the three more because in the first round, 50 teams.
No, they only play 1 match.
The World Cup, they divide the 8 teams, the 2 teams in the groups of 4. 3 teams play the other 2 teams, which is 3 matches.
In the real World Cup, we didn't have all that information there, did we? Oh. Ah. Okay. So you're saying that in the first 32, okay, so that's 4, okay. You get more than 1 chance to play to win. I didn't know I had a soccer expert in here. Wow. Wow. Okay. And it's just like when you play your World Series in baseball, you have the best 4 out of 7. But it could be just 4 games, but it could be 7 games. Wow. So maybe we should not call it soccer. Or we need to call it one elimination game tournament. Okay. Okay, then you would agree with this. Okay. Phew. Well, and then I checked my answer with the author. He agreed with this. He must not know as well as the game of soccer, right? The real tournament. So let's go back there. I'm glad you said that. You can see I'm not a big soccer. We'll call it one elimination. How about that? Is that better? All right, we will write to Marty. I'll see Marty in San Diego. I'll say, hey, Marty, that problem. He'll probably get a kick out of that.
I'm just confused on how this problem here, I don't see how it relates to anything else. Like, how are we supposed to know to do that with this stuff?
It's that situation again of putting yourself in that actual situation. I know.
I would never have thought of
You wouldn't have thought of it.
You know, the permutation or combination.
That is the other reason why I tried to pick as many different types of problems so that you can see how each one works. I'm trying.
Yeah, no.
I'm trying to make sure you get a good, yes.
On there. So
That's a possibility of something like that to be on there. You never would have guessed that, right?
Based off of working with you.
Because you've got that thing, okay, it's 4 factorial, it's permutation where I have more and select some, and if I have and then you're thinking that's my only way to think about I get it, I know. That's what makes, I think, probability a little different. Just like the socks in the dryer at the very beginning. Okay?
So the
Okay.
problem, the B is 1 out of 30.
Well, that's a good question. We haven't got to B yet. Do you agree that and now that I changed the title, there's 31 different games, right? And in part B, it says, if you make a random guess for each game, how many games are there? 31. How many random guesses am I going to make? 31. And find the probability of picking the winner in every game. Well, if I have a game and I have 2 teams playing and I'm randomly guessing which team's going to win, what's my probability for one game? 1/2, 1 out of 2. But how many guesses am I making? 31. So 1/2 to the 31st power. Yes. See, you got it. It's just that with these, you just have to talk your way through them. You have to think about, well, put yourself in the spot. Well, if I'm randomly guessing, what am I randomly guessing? Yep. That's why I wanted to bring these problems back to you before you do your general problems from the entire chapter 4. Okay?